Today's problem is string stack, difficulty medium. You are given two strings, Pat and Tar. Pat and Tar. Oh, I see. Pattern and target, consisting of lowercase English characters. You can construct a new string S by performing any one of the following operation for each character in Pat. Append the character Pat, add I to the string S, or delete the last character of S, and if S is empty, then you just do nothing. So you perform operations on every character of Pat exactly once. Your goal is to determine if it's possible to make the string S equal to the string tar. Okay. So examples here. We can put the G into the string. We can put the E into the string. We can put the U into the string, and then we can use the operation for A to take the U off the string. Then add the E, add the K, we're done. Okay, what about this one? The A, well, we are allowed to skip a character if the string is empty, just not put it in, so we'll do that. Append the G, append the I, then we get to this F, and we use the F to remove the last character in the string, which is I. So now the string is just G. Then we add the F, we add the G, we add the H, and we use the D to remove the H, and we're done. This one, we can't do it for, fairly obvious reasons. These letters in target are not in the pattern in that order. So, I was thinking, why is this called string stack? Actually, also get the constraints and so on. Constraints, the size of pattern and target will be somewhere between 1 and 10 to the 5th, 100,000. So no empty strings either way. Expected complexities n plus m, meaning we're going to take one pass through the pattern, one pass through the target, topic tags, strings, greedy, two-pointer. Okay, greedy. Yeah, it's kind of a greedy. I I thought, why is it called string stack? And it does kind of look like, you could use a stack for it, like something like this. We'll push the G, we'll push the E, we'll push the U, and then we'll get to the A, and then we'll pop the U, and then push the E and the K, and we're done. Then I get to this one. This one's a little bit more of a problem, like the A. What are we going to do with the A? Well, we could push the A, but then we have a problem with the G, because we don't really want the A in the string, but we do want the G. So our options are to push the G, and then we're stuck with the A, or to use the G to pop the A, but then we don't get the G. So that's a problem. We don't really know what to do with the A unless we look forward at the G. The next characters are also kind of a problem there. So we've got I. Now, we don't want I in the string, but do we push it on the stack? We could push it on the stack. If we look forward, we see an F. Now, what do we do with that? Let's see. What are our options? Well, we don't want to remove the G, but if we push the I, then we're going to not be able to use the F. Now, as it turns out, there are two Fs. So it's okay if we push the I and then use the first F to pop the I. But now we get to the I, we've got to look forward two characters. So this is starting to sound a little bit ponderous. And actually, when you find that a problem is difficult unless you're doing a bunch of look-aheads, then you can think about, well, what if I started at the opposite end and worked towards the front? So that is what we've done. That is what we've done here. So let's try to walk through the algorithm. So we'll use this second example here. Starting out, length equals the length of the target, which in this case is 3. We have strings, which we're going to convert to arrays, and the index, target index, is going to start at the end here. Pattern index also going to start at the end here. Now, while the length is greater than 0, which means we haven't found the, we haven't matched the target yet. And pattern index, we still have a chance because the pattern index has not reached the end of the pattern. What we're going to look at is this. Pattern index. Is the pattern index, is the current pattern index character equal to the current target index character? And in this case, the answer is no. It's a G and a D. So what we're going to do is we're going to move the pattern index over by 2, like this. We're going to skip over the H and we're going to move to the G. Now, how do we know we can do that? Well, if let's say the H was not an H, let's say the H was in fact the G that we need. Well, we've got a problem either way, because what are we going to do with the G? Well, we have to put the G on the string. And then we're left with the D. What do we do with the D? We either have to put the D on the string, which we don't want, or we have to use the D to take the G off the string, which we also don't want. So because we're being greedy about this, we're just going to say, look, if there's a letter we don't want, assume it is followed by a letter we also don't want, because we're not going to be able to get to it. So we'll subtract by 2. Okay. Now, go through again. Are the characters equal? And in this case, they are equal. So what we're going to do is we're going to move the pattern index down here. We're going to move the target index down here, and we're going to decrement length. It is 2. Okay, we'll go again. We've got an F and an F. Those are equal. So we move the pattern index down, which is the next F. We're going to move the target index down, which is a G. And length. Length is now 1. All right, go again. We've got a G and an F. They don't match, so we move the pattern index down 2. And that takes us to this G here. Go through the loop again. The characters match, so pattern index goes here. Target index goes off the target, which is okay. Length is decremented. It is now 0. And so we can't go through the loop anymore because length is not greater than 0. So we come down here, and if length is greater than 0, we didn't find we couldn't match the target, so we'll return false. In this case, length is not greater than 0, so we're going to return true. Let's talk a little bit about the fact that we match this G and we still have characters at the beginning of the string that we haven't, of the pattern string that we haven't dealt with yet. So it doesn't really matter what those are. There's either an odd number of characters or there's an even number of characters. Now, obviously, if there's an even number of characters, we can just pair those off. We put one on the string and then we use the next letter to take it off. If there's an odd number of characters, well, in this case, like there is an odd number of characters, but the rules say If there's nothing on the string, then you can just ignore the character. So if there's an odd number of characters at the beginning of the string, we'll just ignore the first character, and now we have an even number of characters, and again, we can just pair them off. Put one on, take one off. Okay, let's remove the writing, and let me just do a quick sanity check. All right, everything is good. And let's go here. I can't remember if I actually tried the, I did try the stack thing a couple times, and I just, I couldn't make it work. It kept getting more and more elaborate, and it still wouldn't work because of, the need to do look-aheads. So, I guess the moral of the story is don't be thrown off by the title. I mean, because really down here, they didn't say anything about stack. So anyway, that's the solution. Please like the video, and let's see, subscribe to the channel. It's free of charge. You should get notifications, new problems becoming available every weekday, and we'll see you next time.